Hey, welcome. This is a linear algebra in Python with SciPy step-by-step tutorial. Today is the first day of this linear algebra tutorial, and in this tutorial, I will cover how to implement vector operations with Python. Basically, vectors are one-dimensional arrays that represent quantities with magnitude and direction. So SciPy, along with NumPy, provides various functions to perform vector operations. In this tutorial, I will demonstrate two fundamental uh, vector operations, which are the dot product. The dot product, also known as the scalar product of the two vector measures the similarity between the two vectors, and it returns a scalar value and defined as the sum of the element-wise products of the two vectors. And the second one I am going to implement is cross product. The cross product known as the vector product as specified to three-dimensional vectors. It is not like a product, I mean, a dot product, but it's just known as a vector product, basically specific to three-dimensional vectors, and it returns a vector that is perpendicular to both input vectors, and the cross product is used in geometry and physics to calculate the normal vector of a plane or to compute turquoise in mechanics. Let's try to see the mathematical explanation of this, the two vector operations. Let's consider two vectors, vector 1 and vector 2. Vector 1 is 1, 2, 3, and vector 2 is 4, 5, 6. And I will perform the following operations to perform the vector operations. The first one is dot product. As I have said previously, the dot product is known as a scalar product or a scalar vector of two vectors that measures the similarity between vector 1 and vector 2. And the result could be the scalar value and defined as the sum of element-wise products of the two vectors. So just multiply the elements of each vectors, and the result would be the sum of the products of each element in the vectors. So this is the mathematical notations of dot product in vector operations. V1 index 0 multiply V2 index 0. For example, 1 multiplied by 1, I mean 4 plus 2 multiplied by 5 plus 3 multiplied by 6. This is called element-wise products, the sum of element-wise products, and the result could be a scalar value, one value only. And the cross product is different from the dot product, but the cross product is also known as a vector product, and this cross product basically is specific to three-dimensional vectors, and the result is perpendicular to both input products or input vectors. So this vector 1 and vector 2 are the cross product is given by vector 1 multiplied by vector 2 minus vector 1 multiplied and so on. And that is a copy a one-dimensional array. Okay, this is mathematically a representation, and I will implement this using Python, and you can easily demonstrate the vector products using Python. Okay, first of all, you have to import NumPy library. This is the most powerful library for numerical computation. Okay, and then the next, let's define the two vectors, vector 1 and vector 2. Vector 1 is, let's say, 1, 2, 3. 4, 5, 5, 6. Okay, now let's find, sorry, there should be comma in each element in the vectors. Now let's find the dot products of the vector 1 and vector 2. To do this, NumPy supports the dot product function, dot product, and we can just use v1 and v2, and the result could be a scalar values. Let's run this product. That is 32 because 1 multiplied by 4 plus, that is 4, plus 2 multiplied by 5 is 10, 10 plus 4 is 14, plus 3 multiplied by 6 is 18, 18 plus 14 is 32. This is called a scalar value. So the result of the dot product in linear algebra or vector operation is called the scalar values. Okay, how to implement the cross products, and the cross product is different from dot product because the result of the cross product is a one-dimensional array. It is specific to three-dimensional array in the cross product, and let's do this using NumPy. NP dots, there is a function that NumPy supports is called cross, and let's pass v1 and v2 as an argument to this function. Let's find the cross product of the two vectors. Okay, so the result of the cross product of the two vectors are a one-dimensional array because cross product basically is specific to three-dimensional array. The inputs are two-dimensional array, and the result or the output is one-dimensional array in the cross product. So this is the simplest way. So you can do this using Python without any challenging, because if you are not good in math, but Python can help you to improve your mathematical skills. Okay, and don't forget to like, share, and subscribe, and follow the next day tutorials about linear algebra with SciPy, step-by-step tutorials, and thanks for watching. Welcome to the second days of linear algebra with Python. In the first day, I have been showed you how to implement vectors in Python, and you can watch the previous video tutorials in this playlist. And today, I'm gonna show you how to implement matrix operations with Python. As you know, matrices are two-dimensional arrays used to represent linear transformation in systems of equation, and we can implement matrices of two-dimensional arrays in SciPy Linang modules, which provides various functions for matrix operations. In this day tutorial, I will cover essential matrix operations. The first one is matrix multiplication. Matrix multiplication is a fundamental operation in linear algebra. It basically combines rows and columns of two matrices to produce a new matrix. And the matrix multiplication is essential for solving systems of linear equations and for various transformation in computer graphics and physics. So this linear equation is very essential for computer graphics as well as physics. So this is a mathematical expressions of two-dimensional array or matrices. Basically, yeah, matrix is a two-dimensional array, but vectors is a one-dimensional array. I have already explained in the first video. Let's consider two matrices A and B. Let's consider two matrices A and B. And I will a matrix A is 1, 2. This is two-dimensional array, and 3, 4, and matrix B is 5, 6, and 7, 8. And I will perform the following operations. The first operation I'm going to perform is matrix multiplication. The matrix multiplication of A and B results in a new matrix. The product of two matrices is another new matrices. And how can we perform this in Python? First of all, we have to import import libraries, import NumPy as NP, and from then once we import the NumPy library, we can perform this using NumPy only. NumPy can support matrix multiplication. And now let's create two matrices. Matrix A is NumPy array 1, 2, and 3, 4. And the matrix B, which is 5, 6, and 7, 8. Now I have defined two matrices, matrix A and B, and I'm gonna multiply the two matrices and create a new matrix from the product of matrix A and B. This matrix multiplication. The product of matrix A and B is we can use NumPy, math, ML. This is very important function that NumPy provides to multiply two matrices, matrix A and B. Now let's see the product of the two matrices. Product. Oh, that's my mistake. Okay, that's correct one. Yeah, the product of the two matrices is another matrix. So this is called matrix multiplication. So we can perform matrix multiplication with Python. And the second matrix operation is matrix determinant. The determinant of a square matrix represents the scaling factor of the linear transformation, which is defined by that matrix. If the determinant is 0, the matrix is singular and its inverse doesn't exist. Determinant plays a crucial role in solving especially linear systems and calculating eigenvalues. So this determinant is very essential. So we can calculate determinants using SciPy library. SciPy library provides the most powerful function that gonna be used to calculate determinants from a square matrix. So in mathematical, we can perform a square matrix. The determinant of a square matrix A is calculated as the determinant of AD minus BC. This is the formula that used to calculate the determinant of matrix A, where A, B, C, and D are elements of matrix A. And so to do this, first of all, let's import libraries. Import NumPy as NumPy, and from SciPy, this is the most powerful library that used to perform a lot of mathematical computations, especially linear algebra, linear equations, and statistics. And we import Linan. This is one of the most important. Then once we import our module, let's define a matrix A. Define matrix A. The matrix A, let's say, is NumPy array 1, 2, and 3, 4. Now let's calculate, find the determinant of matrix A. So the determinant of A is Okay, we can use lenang, which is the SciPy function. SciPy provides this function that used to find the determinant, and we use det function, and we pass that square matrix to this function. Okay, now we can see the result of this determinant of matrix A. Okay, that is -2 or -2. So this is based on the calculation of this. Let's do this manually. Let's say determinant of A is this from our matrix A, we can determine that the first element is A. So A 1 multiplied by the D is the last element, that is 4 minus, and B is this one, the second element in the first row. In the first row, that is 2 multiplied by C is the first element in the second row, that is 3. So this could be 1 multiplied by 4 is 4 minus 2, 6, that is -2. So instead of calculating manually, so we can just use this simple function to find determinant of matrix A. Okay, another most important matrix operation is matrix inverse. So the matrix inverse of a square matrix is that undoes the linear transformation represented by that matrix. So if a matrix is non-singular, which means its determinant is non-zero, it has an inverse. So matrix inverses are crucial for solving linear systems, and they are basically used in various algorithms and computations. So this is very essential, and you can perform this in Python. So the mathematical formulas of finding the inverse of matrix A is we can just divide 1 over determinant of, first of all, we have to find the determinant of matrix A, then multiplied by inversing the square matrix A multiplied. So once we find the determinant of that matrix and we inverse the matrix A, again we multiplied the inverse of that matrix determinant matrix A. Okay, let's do. First of all, let's import the libraries as usual. Import NumPy as NP. From SciPy, we import lenang. And now the next step is let's define matrix A. Matrix A is NumPy array 1, 2, 3, 4. Now let's find the inverse. Simply, without this mathematical notation, we can use a function from SciPy, lenang. We can find inverse of A using lenang dot inv. Then we pass that matrix into this, and we can find that the inverse of matrix A. Yeah, this is the inverse of, this is another matrix, but that matrix A is inversed. And when you inverse this, actually we can apply this. First of all, we have to just find the determinant of the matrix A, as we have calculated in the above. The determinant of matrix A is -2, and we just find that 1 over -2 based on the formulas, the mathematical of minus 2 multiplied by so we just inverse. D is the last element in the second rows of matrix A, that is 4. We just inverse that matrix, and minus B means the second element in the first row, minus B, and we can put that minus C and A. Minus C is the first element in the second row, minus 3, and A is 1. Let's multiply 1 over this means minus 1 over 2 multiplied by 4, that is minus 2, and minus 1 over 2 multiplied by minus 2, that is 1, and minus 1 over 2 multiplied by minus 3, that gives us positive 1.5, because 1 over 2 multiplied by 3 is 1.5. And the last one, minus 1 over 2 multiplied by 1 is minus 0.5. So this is the inverse of matrix A. So easily we can calculate the inverse of matrix A using this SciPy Python program. Okay, so we can do any matrices, matrices operation using Python with SciPy library and NumPy library. To like, share, and subscribe, and watch the next video about linear algebra with SciPy. Welcome to the third days of linear algebra step-by-step tutorial with Python and SciPy. In this third day, I will demonstrate how to solve a linear system using SciPy's linang.solve function. Because SciPy is the most powerful Python library that used to solve linear equations, and I have already made 2 video tutorials about vectors and matrices. You can watch the previous video tutorials, and let's get started. Linear system involves a set of linear equations with multiple variables, and how can we solve these linear equations within Python? Let's consider the following system of linear equations: 2x plus y equals 8 and x plus 3y equals 11. And we can represent this system in matrix form as ax equals b. A represents the matrix of coefficients of the linear system, and x is the variable that's gonna be solved, and b is the constants of the equation 8 and 11. So based on this, we can solve the x, and we can use this formula. So instead of solving using manual system, we can apply this Python program to easily calculate or solve this linear equation and find the x. Okay, now first of all, we have to just import the libraries as usual, and the NumPy and SciPy are very, very important. And let's define the coefficient of matrix A. So the coefficients of linear equations in this matrix are so as you can see in the equation, 2 and 1 in the first row, we have 2 and 1 1 in the second row of the second equation. The constants, the coefficients are 1 and 3. Then we can just determine the coefficients of A as a matrix, and we can find define the constant terms of the linear equation. The constant terms are 8 and 11. Okay, that is B. So NP dot array. This is one dimensional. Now let's solve solve the x of the equation. X is, we can use Linang dot solve function from this SciPy, and we can pass the matrix of coefficients of the equation A and the constants of the equation in the above equation B, and we can find x. So the x values is 2.6 and 2.8. So this is very interesting. Let's see like this. Yeah, 2.6 and 2.8. So we can easily determine the variable x in this, and then once we found the variable x, we can substitute the values of x and find the values of y. So we can solve that using this equation. Okay, this is the third day of linear algebra step-by-step tutorial with SciPy and Python. I hope you've enjoyed in this video tutorial. Don't forget to like and share and write your comment under this video tutorial. Thanks for watching. Welcome to the fourth days of linear algebra step-by-step tutorials with Python and SciPy. And this for the tutorial, I will show you how to compute eigenvalues and eigenvectors of a given matrix using SciPy library. And basically, eigenvalues and eigenvectors are the two fundamental concepts in linear algebra, and particularly in the study of linear transformations. So thus, eigenvalues represent the scaling factors of eigenvectors when a linear transformation is applied to them. Both play a crucial role in various applications such as principal component analysis, especially principal component analysis, very important for the machine learning implementation, and uh, stability and analysis in physics and engineering. So these eigenvectors and eigenvalues are very crucial in this case. The mathematical equations of solving eigenvectors and eigenvalues are very complex, and we couldn't understand easily to find the eigenvectors and values of a given matrix. But we can do this using Python easily without any difficulties, without any challenges. So let's consider this is a matrix A, and the eigenvalues and eigenvectors of matrix A are calculated by solving the characteristics equation of this equation, and lambda represents the eigenvalues, and I is the identity matrix. So the eigenvectors corresponding to each eigenvalue are the solution of the equation, this one. How can we do this in Python? Let me show you how you can solve the given matrix. The given matrix is already here, and let's create the matrix A. NP dot array 1 and 2 and 3 and 4. Yeah, don't forget to import the required libraries, NumPy and SciPy, Linang. And now, once we create our matrix A, we can just solve the eigenvectors and eigenvalues using SciPy. Let's do this. Compute the eigenvalues and eigenvectors. Vectors, we can use Linang dots eig, and we pass the matrix A into this function. And once we done this, we can let's see the eigenvalues of matrix A. Yeah, the eigenvalues of matrix A is this one, and the eigenvectors of matrix A is also this one. So we can solve eigenvectors and eigenvalues of any given matrices using SciPy library in Python. I hope you've enjoyed this video tutorial. Don't forget to like, share, and write comments under this video tutorial. Thanks for watching.